Okay, so today what you're going to be doing is you're going to be reviewing the two types of exponential equations that you've already learned how to solve. The first type is when you're able to make the bases the same. You're given two exponential equations, a base with an exponent equal to a base with an exponent, and you're actually able to make the bases the same. And the second type is when you're given a base to an exponent equaling a base to an exponent, and you're not able to make the bases the same. So, first example, if we're able to make the bases the same. This one here, I have 5 to the 3x plus 2, and I have 1/25 to the 2x minus 9. What I see is that 25, this 1 over 25 is a fraction. So let's go ahead and get rid of that because we want to go ahead and make them the same. So this is 25 to the negative 1 to the 2x minus 9. When you have something raised to more than one exponent, you're going to go ahead and distribute that negative 1, multiply those exponents. So this is really 25 to the negative 2x plus 9. And now I still don't have the bases the same, but I do know that 25 happens to be 5 to the second power. So I have 5 to the 3x plus 2 equals 5 to the second negative 2x plus 9. Again, multiply those exponents, and you get 5 to the negative 4x plus 18. Now that we have the bases the same, we're going to go ahead and set those exponents equal to each other. So 3x plus 2 equals negative 4x plus 8. And then solve for x, step 3. So subtract 2. Add 4x. 7x equals 6. So therefore, when you divide by 7, x equals 6 over 7. Final answer. Okay, so first one that we saw, we were able to make the bases the same. The other type that you've learned about, that you're going to review today, is if you're not able to make the bases the same. So if that's the case, then what we need to do is first isolate the base and the exponent. So let's kind of clean this up. Let's add 4 to both sides. And I have 3 to the x plus 7 equals 24. We're going to change this from exponential form to logarithmic form because I cannot make 3 and 24 be the same base. I can't figure out how to do that. So I'm going to write log base 3 of 24 equals x plus 7. Using the change of base formula that we learned, that means that we would go ahead and take log of 24 divided by log of 3, and that's still equal to x plus 7. So I'm going to take my calculator and type in log of 24, don't forget to close off the parentheses, divided by log of 3, close off the parentheses, press enter, and I get 2.893, let's say. So 2.893 is equal to x plus 7. And now what we'll do is we'll go ahead and subtract 7 from both sides. And I get that x equals a negative 4.107. Okay, so today, first thing I would like you to do is I'd like you to go ahead and complete and correct and turn in the 7-6A worksheet. It's going to be a mixture of both types of problems, being able to set the bases equal and not being able to set the bases equal. Go ahead and make sure you've got those correct. You'll be turning that in today. And then there's a half sheet that's a 7-6 exit slip that's going to kind of make sure that you know what you're doing. I'd like to check your work and see how you're doing. Both the 7-6A worksheet and the 7-6 exit slip will be turned in today.